Welcome everyone to As-Built Surveying Best Practices, presented by, like Camille said, Precision Property Measurements. So, as she mentioned, my name is Cameron Sliderbeck. I'm the Regional Director for our Southern California office here at Precision Property Measurements. I've actually been with PPM about 13 or so years now. And so thankfully been able to kind of see firsthand how the impact of technology has revolutionized industry standards for creating as-built plans. So let's get started. Real quick, wanted to quickly mention AIA Pasadena Foothill is the continuing education provider for this program. And so wanted to go over the course description. It's a little lengthy, but I thought I'd start off by reading through this. So As-Built Surveying Best Practices is a comprehensive course that teaches architects how to create as-built plans prior to beginning their design process. The class is intended to educate the attendee about both parts of the as-built survey process, gathering the field measurements of the structure, as well as using that data collected to draft or model the final plans needed by the architect. The first part of this course focuses on laser scanning, which is quickly being adopted as the main form of field measuring because of its efficiency and accuracy. The second part, the course explains the second step in creating as-built plans, which is to document the existing conditions using the point cloud in AutoCAD 2D drafting software and or various 3D BIM software. When attendees complete this course, they'll understand the full process for creating as-built plans using laser scanning as the main method for gathering those field measurements. So what we'll learn here, we'll learn how to recognize when and how to use terrestrial laser scanners to gather field measurements. We'll know when and how to employ mobile scanners to take field measurements. We'll understand the role that the point cloud plays in displaying data in a usable form. And finally, become familiarized with techniques for drafting and modeling as-built scope items in AutoCAD, Revit, and other BIM software. So we'll cover three major areas here. Number one, laser scanning. Number two, point clouds. And then number three, BIM, or building information modeling. Throughout the presentation, we're going to have a series of polls, which I'll ask all of you a multiple choice question. And please, if we could hold questions until the end, we'll have a Q&A session toward the end. So we can open it for questions at that time, but feel free to punch any questions you might have now in the chat, and we'll kind of monitor those as we run through this. So before we do get started with section one, like I said, our first poll, how do you generate your as-built plans? A, you create them yourself. B, you have an internal team create them, or C, you partner with an as-built firm. I'll give a couple seconds. I need to actually pull up the chat here myself so I can kind of see answers. Yeah, we'll give it a sec.
C.
A, B, or C. We got Scott saying he creates it himself. We got C, but sometimes B. We got some spread there, which is to be expected. Totally makes sense. Sometimes you create them yourself. Other times, maybe the project is just too unwieldy and you need someone else to just kind of tackle it for you. So I see some answers straggling in. Appreciate you guys chiming in. So let's get started with section one, which is laser scanning. So first, we'll start off by touching on technological methods for both mobile and terrestrial LiDAR scanners. So updating or even replacing a proven method for doing something by utilizing that newest technology certainly isn't easy. I know we were talking about that right at the beginning here before most of us logged on here. But really, no matter what industry you're in, that's the case. So the first step you take is certainly the most important, and the rest is just hard work and diligence. Even though it might be difficult to transition, Making the change to laser scanning as a survey method provides you with several things. It provides you with fast data acquisition. It's more accurate than any measurements that could be taken by hand. It reduces the odds of human error dramatically in the field. This tech can be purchased, rented, or contracted, so there's flexibility there. It's a thorough solution. It allows surveyors to gather more data um, than needed to complete most projects. And then finally, it provides a digital twin to pull additional data down the line if the project ever needs to be revisited or additions need to be made to the scope of work. So what does LiDAR mean? We hear about it in the news, various articles about autonomous vehicles, robots, that type of stuff. And it's the same technology that we use to get survey data. It stems from the word radar, which stands for radio detection and ranging. That's a much older technology, of course, but this works in the same way. Um, LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. And each one of these illuminations can be considered a measurement. And then finally, each single measurement is logged. And throughout the course of the scan, millions of measurements are taken in all directions. So let's talk about some LiDAR scanners currently used for architecture, engineering, and construction. So when we need very accurate measurements or a lot of intricate detail captured for historical projects, Joe, you were mentioning that earlier on, maybe structural or engineering analysis or prefab projects, we go to our favorite terrestrial scanner, and that is the Leica RTC 360. So even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are still relatively short compared to other terrestrial scanners, making it the faster terrestrial or fastest terrestrial option out there, really. The iPad app also allows or helps make sure that you can check your point clouds before leaving the job site. The RTC 360 is extremely precise and gathers so much data that point cloud files can be over 500 gigabytes. So huge, huge files. Whether we use the onboard camera to make a color point cloud or not, we always get very dense, very accurate data that allows us to draft and model ornamental detail, pipe valves, other intricate details with high precision. Because our final data is made up of hundreds or even thousands of scans performed with this scanner, it makes it ideal for the starting and stopping sometimes required in busy spaces like hotels, shopping malls, industrial spaces, things like that. With the RTC 360, you can scan up to 100,000 square feet in mere hours. Though this obviously does vary by construction type and density, things like that. It's not cheap, costs about $78,000, including software, but super, super useful tool. In the next slide, we'll see a short video actually of a scan taken with this scanner. So while other scanners can be moved while they're operating, the RTC 360 needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot that you see here is a place where we strategically position the scanner to gather the black and white data you see. Even though we did not use the camera for this data, you can see how much detail we can get using the black and white measurements gathered. Each black and white point or pixel is a representation of an actual laser measurement, it's accurate down to less than 2 millimeters. This means that the entire 3D picture you're looking at is truly dimensionally accurate. For this particular project, we use this data to help an architect identify floor sagging and wall sagging and other kind of structural issues before a major remodel of this 100-plus-year-old casino that was in Colorado. And just for a quick reference of a final result of a project completing the RTC 360, here's a Revit model. This was of the Olympia Hotel at Capitol Lake in Washington. And then here's that same property that I just showed you, kind of showing the point cloud layered underneath the Revit model. This was actually 178,000 square feet of space. Took us a good 170 some odd man hours to model in Revit. So we've chatted a bit about terrestrial or stationary scanners. Now let's dive into a couple of our most commonly used mobile scanners, and that would be the GeoSlam Zeb Horizon and Zeb Revo. So some general points regarding mobile scanning and processing. Using a mobile scanner is definitely preferable if you need accuracy and your time on site is limited. Since most individual scans take only 15 to 45 minutes, we recommend you process the scan on site to make sure you're checking your results before you leave. Once the scan is complete, you need to use the SLAM algorithm software that's included, which interprets all the measurement and movement data from the scanner to produce the 3D point cloud. After that SLAM algorithm produces a 3D point cloud, you then proceed to review the point cloud to ensure accuracy. Most errors in scanning or processing can be spotted pretty quickly, and actions such as rescanning can be taken to ensure the overall accuracy of your project when the time comes to draft or model. We'll actually touch on these potential point cloud errors in a few slides as well. So this is what point cloud data looks like in plan view. You can see that even though there's no photo-based colorization of the points, these points are colored on a height ramp, so to speak, where points at different heights are shown as different colors on a spectrum, which you can see there on the left. Red is high, or is a lower height, and blue is a higher height. Coloring the points this way makes it easier to see important features in the point cloud, even without the photo colorization. So there's two types of GeoSLAM mobile scanners, like I mentioned a couple slides ago, the Horizon and the Revo. The Horizon scanner, as shown here in this picture, is one of our favorites. The scanner reduces the time spent on site, scanning up to 90% compared to terrestrial scanning because of the fact that it's mobile. Collects 300,000 points per second with a 6 millimeter accuracy, and it covers a range of 100 meters, so far, far distances. You can pretty much use this to scan anything visible, of course. We've used this to scan single-family residences, commercial spaces under 50,000 square feet, restaurants, retail spaces, warehouses, you name it. You can scan up to 50,000 square feet in mere hours, and this varies by construction type and density, of course. And this scanner is about $45,000, including the software. And then here's an example of a project that we scanned using the Horizon. This is a 9,000 square foot single family residence located in the DC area. Their client actually requested a remodel package, which includes floor plans, roof plans, and exterior elevations, as well as still photos. And now this is the Revo scanner, as pictured there. And just like the Horizon, it reduces the scanning time by up to 90%. This scanner collects 43,000 points per second with a 6 millimeter accuracy. And again, like the Horizon, you can scan up to 50,000 square feet in hours, and does, of course, vary by construction type and density. And this one's just a little bit cheaper at $33,000, including software. So here's an example of a floor plan overlaid onto a point cloud for a single family residence scanned using this Zeb Revo. This was a 2,700 square foot SFR in Venice. And they got floor plan, roof plan, elevations, electrical, and sections done. And then here's an example of a mixed use project we scanned using the Revo. This was a 27,000 square foot building located in Seattle. And the client actually requested floor plans, roof plans, exterior elevations, RCP, and interior elevations. And this image is what the RCP particularly came out to look like. And as you can tell, it was super dense, really dense project. It took us about 8 hours to scan on site, though. So the scanning certainly cut down on that time on site, whereas that old school method of doing it by hand, this would have taken days. And then next up, we have section 2 regarding point clouds. So reviewing your data really well before attempting to create a set of as-builts from a point cloud is a absolute must. If there's any kind of errors with your cloud, which certainly do happen, from time to time, then using that bad data can either stop you in your tracks later when you're drafting or modeling, or even worse, result in just an entirely incorrect set of as-builts. Once your scan's processed, you'll need to review the output. Did you make sure that you covered all the areas? Are there any flaws or errors? And then ensure there's no drifting. And we'll touch on what drifting means and what that kind of looks like in a little bit here. So most scanners have a range of hundreds of feet, which can produce a lot of data outside your project that you very likely don't even need. You may need to clip or crop your point cloud to reduce that file size by getting rid of this unwanted data. If you have to produce multiple point clouds for a large or complex project, it'll be important to get comfortable with point cloud software that will allow you to merge or register your clouds and then more easily manage that data. So to reiterate that, since there's scanners, those scanners have such a wide range, you're going to want to trim or crop those point clouds to eliminate the excess data that you don't need from those long range scanners. For large projects, utilize point cloud software to merge and streamline data management. Much like the traditional method of hand sketching and measuring, properly scanning a structure takes a lot of practice and in order to do correctly and efficiently. Once you're practiced with scanning and know what to kind of look for when errors may have occurred, you'll have the most reliable version of data you can possibly gather in the field. You can be confident that the as-built you create will be fully accurate and ensure a smooth and safe renovation as it progresses. So a couple areas of that cause some trouble here when scanning attics, foundations, large, exterior sites, multi-level structures. You may run into issues getting all your data to fit together. Areas that are hard to access, like have lots of reflective surfaces like mirrors, or have fewer unique features like office hallways or open empty spaces. Those can all kind of pose a challenge. So processing requires all areas to have data connecting one area to the other so they can be kind of properly glued together. Mirrors, moving objects, etc., can also trick the process and therefore give you bad output. The screenshot that you actually see here is of a multi-level structure, and it's a space with kind of fewer unique features. It's just columns and open space. And additionally, that open space really did pose a challenge as a result. So, as I mentioned before, drifting, make sure to look for any of that drifting, which can occur when the software has trouble putting all the points together. If this does occur, then you can try some reprocessing options or just simply, rescan the structure. Drifting includes reflection noise, other data noise, needing to use other devices for control on larger buildings, internal scanning errors, mirrors reflecting data, like I mentioned in the last slide, and then just duplicate data. It's important to keep an eye out for multiple types of drifting inside and outside of the building, and there's a kind of visual example of that. So drifting is super, it can be common with mobile scanners, and it occurs for several different reasons. Being able to determine what that reason was is super helpful before attempting to reprocess or rescan. So now that you've collected the data using the methods we discussed earlier, it's time to create the actual plan sets. However, before we move forward to section 3, building information modeling, I'd like to pause here for our next poll. And this one's a simple one. Which software do you work in? There's a number of options there. A, AutoCAD. You plan to always work in AutoCAD. Or B, you do work in AutoCAD, but you are interested in working in other software soon down the line. C, Revit, D, ArchiCAD, or E, SketchUp, kind of the 3D options there. So feel free to punch your answers in the chat, and I'll give everyone a few minutes to do that. So yeah, a good mix of answers here, and that's kind of what we see too. There's a lot of our clients work in the 2D space still, and therefore work in AutoCAD, but that 3D Revit or 3D modeling is starting to kind of take off too with the Revit, ArchiCAD, or SketchUp or other other programs as well. Cool. Well, thank you guys for responding to the poll. Let's get going. So let's dive into drafting from the point cloud. So when you're drafting from a point cloud, the first thing you'll need to do is get into a drawing environment. Point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software. If you use Autodesk products, you'll need to use an application called Recap to prepare that point cloud to ensure it works within their entire software suite. Drafting from a point cloud in AutoCAD is mostly straightforward, but it does take some getting used to. And then finally, point clouds are ideal as built data sets for creating Revit models, but the Revit point cloud tools can still feel a bit lacking. So let's first talk about CAD drafting from a point cloud, specifically in plan view. So in the image here, it's an example of a slice of a point cloud in plan view. Regardless of how you get your survey measurements, it's good to start any as-built by starting with the floor plan, of course. When you're drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally so that you can use the ortho function in CAD to easily draw those lines. If you're going to work on elevations or need to extract any heights from the point cloud, it's also good to position the point cloud in the z-axis. Typically, we start by lining up the finished floor surface of the first floor at a 0, 0 datum point. Once you have that point cloud well positioned to begin your drafting, you should be able to derive all the walls, doors, door swings, and any other visible architectural and structural information right there from that point cloud. Some items like windows, those can pose some difficulties when you're trying to extract width and height information. But with diligence and practice at manipulating the point cloud, it gets easier. Some scanners will not pick up smaller items, especially if they're flush with the walls or ceilings, like can lighting, electrical switches or outlets, things like that. Trying to locate them in the cloud can be pretty time consuming. And in that case, sometimes it's better to just use the more traditional measurement tools while in the field and just sketch and measure those items. So now let's get into drafting other views, such as an elevation from the cloud. So when you're working in a 2D and drafting environment, it's not only important to have your point cloud well oriented in the drafting space, but you'll need to be well practiced at manipulating the coordinate system views and the point cloud sections. So once you do, you'll see that this is where there is a huge advantage in having a complete point cloud for drafting, provided that you were able to actually access the roof and scanning, which can sometimes be a challenge. You'll have a complete picture of not only the roof behavior, but also every height that you're going to need to properly draft your roof, exterior elevations, and potentially any section cuts that you might need. As with electrical and RCP components, sometimes it's beneficial to revert to those traditional methods, as I mentioned before, to kind of sketch elevation ornamentation items that you'd like to include in that drafting. So now that you've seen how we set up the point cloud in AutoCAD for drafting, let's also examine how this setup works in Revit. So the level of development or LOD system was created for the AEC community to put standards on BIM drawings. Describes the different ways in which 3D objects can represent existing or design elements in a BIM model, with level 100 being the lowest, meaning you're just kind of massing your objects roughly, and then level 500 being the highest, with that being so detailed and exact that you're essentially building a virtual version of the structure. When modeling as-built plans, we've found that LOD 200-ish is usually the most applicable range, since you're assessing a structure that's been built kind of from the outside. With many interstitial spaces being inaccessible, the specific construction of many architectural and structural elements cannot always be determined, which is required for LOD 300 and above. So first, let's talk about modeling the plan view items from a cloud in Revit. So when you're modeling in Revit from a point cloud, you're going to want to ensure that your cloud is positioned orthogonally in plan view. so that you can use the ortho function to place walls. Then set that finished floor to your 0, 0 level, and then create and set all other levels to key features in the point cloud. Once you're done setting the finished floor, you can start adjusting your view range and view depths in your plan views to add wall, door, window families in the places indicated by the point cloud. And then similar to drafting in AutoCAD, the first thing you need to do to work with a point cloud in Revit is make sure that it's in a recap project format for use with Autodesk products, at least. Using the point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all elements of a building related to each other in a set of 3D drawings can be valuable to your design and planning process because you can see the way things interact with each other in a way that you can't really do with a set of 2D drawings. Viewing the point cloud and model in 3D provides even more information about how structure, MEP systems, and architectural interact, or architecture interact more than you would find with a model alone. And finally, building or modeling an as-built in Revit may seem overwhelming at first, but as long as we've got a solid order of operations for creating a usable Revit model, that'll go a long way. So now going from plan view into modeling vertical information. So as with AutoCAD, this is where there's a huge advantage in having a complete point cloud for modeling. Drawing sections and adjusting section depth is crucial to viewing point clouds effectively while you're adjusting window heights, door heights, and creating roofs. Practice patience. Roofs are certainly tough, tough to model, but even more so when you want them to accurately match a point cloud. So there's some advantages to having a BIM as built, which some may not realize. Sometimes a three-dimensional model is only really considered for like a presentation for design purposes with your client, but it can also be useful as an as-built as well. The as-built BIM model can be viewed in multiple phases, so you can easily switch between existing, demo, proposed, and alternative proposed phases. When you have a BIM model moving from the design phase to the construction documents phase of a project, it's far more efficient. Having an as-built BIM model can make it easier to understand a project that you haven't maybe visited yourself or been able to visit yourself, since you can cut sections, view interior spaces, review roof massing, all that stuff in 3D. And then some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or planning departments. So now it is time for our last poll of the day before we jump into our Q&A. And that is, what is the most important factor to you when obtaining your as-built plans? Is it A, quality and accuracy, B, timeliness or turnaround time? Is it C, efficiency, or D, cost? And again, I'll pull up the chat here. Hopefully we get some responses. I would imagine A is going to be the common one there. Yeah, Kevin, all of the above, of course. Those are all important factors, but yeah, I see A, quality and accuracy. I mean, if you don't have a high quality or accurate as built, all that other stuff, goes by the wayside anyway. So I figure that's kind of what starts everything off with a good project. Great, thank you guys for chiming in. And I think we are onto the Q&A. Real quick though, I actually wanted to jump ahead because I wanted to remind everyone, in case people log off for some of the Q&A session, that we have the raffle for a Lego set. We're going to be raffling that off. We'll choose offline. We'll do a raffle in our office with Amber, my coworker Amber, and we'll be in touch with one of you attendees to let you know that you were the winner. So we'll be in touch in maybe a week or so. But now let's get to Q&A. Did any questions come in? I think I saw one question pop in there.
Yeah,
Yeah,
we
yeah.
got a question which is, can you combine point clouds from
Yep.
different scanners?
Yes, I saw that one. That was a great question. And the answer is yes. That now for the smaller, maybe single family projects, that is rare and won't be needed. But for the big stuff, we'll usually use maybe mobile scanners inside and terrestrial scanners on the outside to kind of get our control locked in. So the answer is yes, that can be done.
Hey, Cameron, quick question.
Yeah.
What is your typical turnaround time, for an average building? And let's just, for
Yeah.
the sake of discussion, just say it's a 20,000 square foot commercial building.
20,000 square. I would say it also depends. One of the biggest factors is what we're getting, right? As far as if we're just doing a floor plan versus doing the whole kind of kit and caboodle. But something like that, our standard turnaround time is about 3 weeks on average, I think, for the last year and a half. So give or take from there, depending on the size and complexity of the project, for sure.
Great. Thank you.
Okay.
Are there dangers? Yeah, I'm reading the chat here too, Camille. Are there dangers for the general public from using scanners? Not that I know of. It's not the laser itself is not visible. But yeah, we scan properties all the time where people are even driving around. We're scanning along a street side and things like that, and that's not a factor. Um, Applicability to complex terrain, contours. So yes, that can be done. Scanning an exterior, something maybe on a hillside or something like that, you can get spot elevations or I guess draft contours. We don't personally do the contours ourselves since we aren't licensed land surveyors. But yes, you can, Joe, get that information from laser scans. Rachel, do you have a process to check scans against as-built drawings? So do you mean after the fact, like maybe unmute and let me know what you mean by that? But I know that's how we do our entire quality assurance process is we draft or model um, from the point cloud during the drafting and modeling phase. And then our QA person would get in there, underlay the point cloud, make sure everything lines up. I hope that kind of answered your question.
Are unmuted.
Hello, can you hear me?
Now we
Yeah, I can
can.
hear you.
Okay. Yeah,
I
yeah,
saw
yeah,
your other
sorry.
chat too.
Yeah,
Hi,
just,
Rachel.
hi, usually we do have original drawings to start with, but having an extra
Yeah.
layer of the scanning helps us, maybe hopefully the intent is to be more accurate. So I didn't know if do you include those kind of original drawings to check against, or, is that part of your process at all, or is it truly just starting with the scanning and turning that into?
Yeah. Good question. We certainly have a lot of clients who say we have these old plans and if they're useful, use them. If they're in CAD or Revit or something like that, we could certainly do that. But it takes just as much time to like cross-reference all that stuff against the point cloud than to just start with the scanning, like you said, and model it from scratch. So as our own company, we don't really verify existing drawings. We just start from scratch. But I'm sure there are people who do that. But it can be done though, to answer your question. Do you use drones? We do. That's actually something we're rolling out company-wide this year, is getting all of our surveyors on all of our teams. We have several regions across the country, and getting all of our surveyors drone certified, pilot's license and all. So right now we have, I think, two of our surveyors, one of those being in Southern California. So if that's something of need, reach out and I'd be happy to talk about it.
I think there's a question that got
Look over
passed
anything.
over, which is, does the software tell you where to place the stationary scanner for best results?
That's a great question. And I don't believe, no, the answer is no to that. Typically, depending on the type of property and the amount of space you're covering, there's a manual that comes with this, right? And we get trained on it anytime a new scanner gets rolled out and we buy that scanner. But it's not, the software doesn't speak back to you until it will after the fact, right? When you process your scan and you'll see that there's a void area that wasn't covered, that'll indicate to you to go back to that area and get a little bit more coverage. But as far as like, all right, now like placing on on an iPad or something, placing a spot to exactly walk over to and scan, walk over to and scan it, it doesn't do that. But the answers will yield themselves quickly once processed.
Hmm.
Can the scans see below vegetation and dense landscaping? So that's a good question and something that maybe wasn't covered terribly in the presentation, but the scanners will shoot until it hits something. There's no X-ray technology to it, so to speak. So if there's vegetation, it's going to shoot to that vegetation, and that's as far as it's going to go. So you'll see that vegetation in the point cloud, but you're not going to see beyond that. So that can be kind of tricky when we're scanning maybe an older home that's covered in ivy or something like that, right? That's when those kind of using those traditional methods to kind of supplement the maybe the inaccuracy of the scan data in those areas becomes necessary. Hope that answered your question. Yeah, good question, Mehmet. For challenging spaces or when you need detail, outlet locations, for example, are there any tools like stickers, props, flags to help solve issues or focus the device to get details? Yeah, we set targets out. In those scenarios, I think one of the slides shows some fuzzy scan data of an office space that was completely cleared out and just had some columns, and that kind of created some troubles with the scan data. Those in times like that, typically we'll set out some targets. And I'm not sure where we get that stuff, but and then also with we talk about mirrors or like reflective data that can really mess up the scan data. In those instances, we bring butcher paper and tape it up on the mirrors. It doesn't have to be perfect. It doesn't have to cover like every square inch of the entire mirror or whatever the reflective surface is. But as long as that gives a better surface for the scanner to shoot to, so it doesn't mess up the scan data. And then for the outlets, real quick, Mehmet, just to answer your question, yeah, you could go around and put targets or something like that or flags on each of those areas. That would take just as much time though, as just hand sketching the electrical plan. So that's what we end up doing for that kind of stuff. Good questions though. This is great. Anything else? I know we're sort of coming up on time. I think we have till 1 or so. Yeah, thanks, Amber, for putting my info in the chat. If you guys do have any other questions that maybe come to you later on, feel free to reach out to me. I'm only a call away. We can hop on, chat about whatever you want. Yeah.
You have
And
time for another question?
Yeah.
Okay. Quicker to say it than to type it in.
Sure.
If you're surveying, are you scanning a large space such as that that vacant office building that you showed us a while
Sure.
ago? And there would be a lot of partitions and so forth that would be intervening in filling in the overall space. Do you have the capability to get the overall dimensions of the space? Just as, you know, one in the old days of doing this manually, you would just do, say, a running dimension, you know, take
Right.
it off, and it would does this add up all those little things with perfect accuracy, or do you do something else in order to get the big overall dimensions?
Yeah, great question. And that's something that we actually touch on in another one of these presentations that I don't believe is touched on here. But the answer is yes. It definitely gets that with an incredibly high accuracy on the inside. Now, of course, what about the outside? So our process, I don't know about other companies, we have to scan the exterior as well so that we get a tight locked in footprint, because we know if you just add up a ton of small dimensions over the course of time, and if one of those is wrong, or it extrapolates quickly. So we get that exterior scan to get the footprint locked in, and then also scan the interior, and that kind of solves that.
Thank you.
Yeah, good question. Richard has a good question. How do scanners deal with water? Um, we have actually had, I can think of right off the top of my head, we had a client ask us to scan a pool, which is rare, right? But we're never asked to do stuff like that. But it was an interesting one, and we took a shot. We thought that the pool would be empty at the time that we were going to scan it, and it was not. And if I'm remembering correctly, that messed things up. It doesn't like shoot through water. I think that's one of those sort of reflective surfaces, if you want to call water a reflective surface, that can throw off the data. So we had to eventually, I think, have him empty the pool, or maybe we went and did it by hand, the interior of a pool, to kind of supplement the loss of some of those measurements. That's a good question, though. Well, if we don't have any other questions, like I said, feel free to reach out. If anything pops up. I'll stop sharing now and then hand it back to you, Camille. Thank you very much. And again, we'll be in touch.